Hey guys, hope you guys are doing great. Today's topic is going to be about blockchain security. I'll be sharing with you my thoughts on the blockchain X.O phases, the different phases this technology is going to go through. So, moving right along, the topics of today's discussion are going to be blockchain background, the use cases, blockchain X.O, smart contract, the weakest link, security considerations. Blockchain has been discussed for a while now, and in my eyes, there are pretty much three deployment types of blockchains: the public, private, and hybrid. And most of the deployments have been on the public side, and they are pretty much the Bitcoin, Ethereum, Litecoin, etc. Blockchain has been discussed for a while now, and in my eyes, there are pretty much three deployment types of blockchains: the public, private, and hybrid. And all the use cases of the public blockchain have been in the area of cryptocurrencies. Besides the cryptocurrencies, there has been no major uptake of the private deployment of the blockchain by the enterprises. Anywhere I go these days, the discussion always evolves around, and a lot of people are talking about blockchain as a godsend. It is a cure for all problems. It's going to solve all issues, and it's going to solve world hunger, and world is going to be a pretty place once everybody starts using blockchain. So the truth is, blockchain technology was introduced in 2009, and since then there has been no other massive use of it besides the cryptocurrencies. As I said in the previous slide, its only use case has been cryptocurrencies. Anywhere else, everybody's just trying to see what it is, but the snake oil salesmen are pretty much trying to sell it for anything and everything. So it is key that before you embrace the blockchain technology, you look at what requirement is it addressing. Is there a requirement for you to go to blockchain at all? So don't just go into it just for the sake of it. There are enterprises who are conducting proof of concepts on blockchain, and which is okay. They can do what they want, but right now the industry is looking at pretty much blockchain is like a hammer, and everything looks like a nail. So anything and everything, blockchain is going to solve. Blockchain X.O. In this slide, I talk about the evolution of the blockchain technology since its inception. So if you look at the table in the slide number 5, blockchain 1.0, I call these Bitcoin, Litecoin, Dogecoin. So these were the first incarnations of blockchain, and the main use case of blockchain or the cryptocurrencies, hence the Bitcoin, Litecoin, and Dogecoin. The next phase, I would call it, is a blockchain 1.5, which improved on the blockchain 1.0 technologies by introducing privacy into the mix. Because in blockchain 1.0, everything was transparent. Although people said the transactions on the cryptocurrencies were anonymous, they were not really anonymous, they were pseudonymous, where if somebody knew the public address of someone, then they could pretty much track where they were sending money, where they were receiving money from. But even in that blockchain 1.0 era, if you were not using the same address all the time, then you could pretty much obfuscate that activity. But the key was that you had to make sure that you used new address for every transaction. The introduction of the blockchain 1.5 technologies such as Monero, Zcash, Zcoin, they introduced the ability to anonymize the transactions at the blockchain level, so not a lot of information was available. Then came blockchain 2.0. Ethereum is an improvement on all. It's pretty much an improvement on the blockchain 1.0 technologies, where it said instead of creating a new cryptocurrency every time you had to fork an existing blockchain and introduce some additional code into it. What Ethereum meant to do was they said they will introduce a platform which would allow creation of cryptocurrencies programmatically. And to do this, they introduce a concept of smart contracts, which would be the code that you could write to implement your cryptocurrency without worrying about the nodes, the mining, and all that complicated stuff. But if you look at it, going from 1.5 to 2.0, Ethereum still does not have any implementation of privacy in it. The new version of Ethereum is going to have that implemented in it, and I think Ethereum is going for the ZK snarks, but that is yet to be found out when they do implement it. The next phase of blockchain, as I call 3.0, would be, as you can see in the list, EOS, Neo, Hyperledger. So these are an improvement over Ethereum, where Ethereum introduced its own programming language called Solidity, which has its own issues. But EOS and Neo said, okay, we will allow a whole bunch of existing smart contract languages to be used, such as C Sharp, Java, JavaScript, or whatever you want to use. So EOS has a bunch of languages it supports out of the box. There's some that are being worked on. Same thing with Neo, and same thing with Hyperledger. The next evolution in my eyes is the blockchain 4.0, where we have technologies like Polkadot, Dfinity, Tezos, which are pretty much introducing more concepts on the platforms that blockchain 3.0 has already introduced. So intra-blockchain operability, consensus mechanisms, where if you wanted to change certain aspects of the blockchain, you would have to go through a consensus mechanism, and only through that you could have those changes implemented into the blockchain. One of the key, and when I talk about this, I'm talking about Tezos, which is planning on introducing that. Hopefully sometime in summer they should go live. Smart contracts were introduced by Ethereum in 2015. This was, again, as I said in the previous slide, the mechanisms for automating and making a platform that allowed people to create their own cryptocurrencies with the whole bunch of logic in it. But it is not to be construed as a legal contract. The usage of the word smart contract came about when Vitalik Buterin was doing some work on another fork of a blockchain for a project, and they had to write some code for that, and they said we call it a smart contract because it was pretty much automating some activity, and hence the name smart contract was coined, and it struck that way. But what's confusing is that people seem to be thinking of a smart contract equivalent to a legal contract. No, both of these are not equal. If you went to a lawyer, lawyers don't speak smart contract language. They speak their legalese, and they will only talk about their stuff, and they would not sign off on any smart contracts. So just be aware of that. And coming along to the theme of this show today is security. The fact that you can write a a bunch of code to do certain activities for you introduces inherent risks, because it is code, it is written by human beings. There have to be sooner or later there are going to be some bugs in it, and when something has bugs in it, those bugs can be exploited by people and bad things will happen, such as the DAO hack that happened in 2016, where a smart contract was had some code issues in it, and somebody found that hole and they exploited it, and they ran away with about $150 million worth of ether. The weakest link in this whole equation so far has been the smart contract, which is not really the blockchain itself. Blockchain inherently is very secure. No one has been able to hack it or change it or crack it. So it is a secure technology. But what happens is people who are using the blockchain, they have their mechanisms to use the blockchain, and this mechanism at this point of time, because cryptocurrencies are prevalent right now, is the wallet. And when you are writing stuff to the blockchain, blockchain says you have to make sure that there's a private key and a public key exchanged. And you as a wallet owner should have the private key, and public key you can give to anybody else. But if the wallet owner as such does not protect the private key or the secret to the private key, then they might be susceptible to phishing attacks. So all the hacks, all the losses that have been incurred so far have been due to the fact that the wallet mechanisms are pretty complicated, and people forget their keys, people lose their keys, and people don't protect the keys intelligently, and that's what makes them lose their cryptocurrencies. But in a real use case, what one has to look for in a blockchain from security perspective are some of the things that that any security practitioner would be looking at in any kind of a deployment. So as the blockchain platforms get more complex, the threat vectors also increase exponentially. So we need to focus on these areas as I've listed below. Cryptography is the key. The consensus algorithms, the identity, authentication, authorization, code development practices, data integrity, encryption mechanisms, incident response. So coming to key management, as I said before, your wallet, when you're using your wallet, your keys are very important. So you have to protect your private keys. The other piece is when you are creating the blockchain itself, there's a key ceremony required for that to generate keys for the blockchain itself. And if that mechanism is weak, then you're going to have issues. What kind of encryption are you using in the blockchain? That is key as well. What kind of hashing functions you are using in it, and all this is tied up together in a nice package via the consensus algorithm. So if the consensus algorithm has flaws in it, then everything else is going to get messed up as well. So you have to make sure the consensus algorithm that you select, you do your due diligence in selecting the consensus algorithm and its implementation. So again, consensus algorithm in its own right is a piece of code which needs secure development practices such as code review, code testing, black box testing, white box testing, all kinds of stuff that goes up with any code. So you have to make sure that you have that bulletproofed. The next piece is identity. As the blockchain platforms advance and they become more complicated, and this is not really an issue at this point of time in Ethereum, but EOS, and then the new platforms are introducing it, and the idea about authentication. So the machines or the users need to have authentication implemented, and again you have to make sure the authentication is strong authentication. You don't lose credentials easily. The authorization piece, to what level of access are you providing once somebody's authenticated into this blockchain environment? Then what is this actor able to do? Are they able to modify things, or are they able to read stuff? So authorization is important as well. So you need to keep an eye on the authorization mechanisms. I already spoke about code development practices. Data integrity is, if you are writing pieces of code into the blockchain, you have to make sure that data that is being written to the blockchain and being read out of it, its integrity is maintained. Currently in blockchains, you can't write a whole lot of data. You can only write very small pieces of data to it, but it is a repository where you can make references to data in other repositories. So that's one area that you need to look at. Encryption mechanisms, as I've said before, that is key. You have to make sure you're not using weak encryption at all. And finally, the incident response. So whatever infrastructure you deploy for your blockchain, that is, if you do use blockchain for your organization, you have to make sure that you have documented processes for incident response and monitoring for incidents. So the whole infrastructure that this blockchain is going to be sitting on, make sure you have the proper monitoring in place. You have documented procedures for responding to incidents. You have intrusion detection, intrusion prevention mechanisms. So as you can see, the blockchain is no different from deploying any software in your, or any platform in your environment. As long as your requirements are clear, you understand what your needs are, what you're going to be implementing it for, then use those same delivery methodologies. The fact that you are deploying blockchain shouldn't really change anything for you. If you have strong security practices being practiced in your organization, then looking at deploying a blockchain technology should not be rocket science. It should be just following the regular project delivery methodology, taking care of the regular security requirements. Hey everybody, hope you found the information I shared with you today to be useful. Please like, subscribe, and share the content in your social circles. If you want to contact me, my contact details are on my website, secinoid.com. The address is also at the bottom left hand corner of the slide deck. And finally, the information I have shared should not be used as financial advice. So play the cryptocurrency investment game at your own risk. And lastly, thank you for your time, and talk to you soon. Bye-bye.